Power losses on PV solar fields, sensitivity analysis and a critical review. Much efforts are made around the world to mitigate the global pollution as well as to provide humanity with a secure and sustainable energy source. This research comes within these efforts to try to understand the causes of energy losses in the greatest inventions of the last century in the field of converting solar energy into electrical energy. Advantages of PV solar technology from the rest of solar applications encourage the scientists and engineers to make further efforts in order to improve the efficiency of the PV solar panels and as a result to reduce the cost of the electricity production. The study showed that the thin-film solar modules are the most suitable for Libyan climate, which is characterized by high temperatures in the summer season, and it is different from the type prevailing in the Libyan market nowadays. Keywords: energy losses, Libya, PV solar panel, shadow. Introduction. In September 1882 the world's first coal-fired public power plant was built in London. Since then, electricity has been considered one of the most important elements of life and development for the mankind, and since then this industry moves from one stage to another and extends to all populated areas. However, its economic and environmental problems cannot be overlooked. The fluctuation of the price of fossil fuels and the approaching depletion of them and the amount of pollution caused by the traditional electric power plants that depend on burning fossil fuels, which cause global warming and climate change. 1,2. For these reasons, efforts were combined at the Paris Conference to reduce greenhouse gas emissions, and most countries signed the pollution agreement. Among them is the state of Libya, which has approved several legislations for its part, including the adoption of a carbon tax policy. 3. A strategy has been adopted to the transmission from the traditional energy industry to the renewable energies that available in the country. Solar and wind energy, which exist in economic quantities, making them the first candidate for exploitation during the next few years. Especially, Libya and the energy sector in particular are experiencing a large deficit in the security and continuous supply of electrical energy. The shortage in electricity reaches long hours. For example, in Brak City, it recorded for the period of July 25 to September 7 about 57.2%. We believe that the way out of these issues is the wide exploitation of the renewable energies at the domestic and commercial levels. 4,5 instead of the small mobile generators which cause damage the environment and national economy. 6. According to studies specialized in the field of renewable energies, the Mediterranean basin is rich in solar energy sources, as well as wind energy sources. 7. Libya locates on the solar built zone and has a high potential of solar energy. The potential of wind energy is remarkable also, especially in some coastal and mountainous areas, such as the city of Derna in the northeast and the city of Meslida in the northwest. 8. Looking at the distribution ratios of electrical energy represented graphically in Figure 1.9, we find that the household sector consumes about 31% of total electricity production and is the largest sector consuming electrical energy in the country. As is the case in most developing countries, this percentage is greater than the deficit ratio. In the general generation of electricity, if 75% of the household load was covered, the country would have recovered from the electricity crisis that we have been dealing with since 2011 until now. So the solution is divided into two parts. The first part is to use solar heaters to heat water, which constitutes about 30% of the house load and equivalent to 9.3% of the total load, as well as the use of solar cooling systems, and this will cover 18.35% of the household load, equivalent to 5.7% of the total load of the network general electricity. This part, the thermal application of solar energy, has been discussed in many local papers. 10 to 14. The electric power crisis and the high price of fuel pushed many companies tend to import solar systems, solar panels, storage batteries, inverter, etc., and many residents accepted to install these systems on the roofs of homes. In fact, the Libyan market does not have experience with such systems, and therefore it must be noted that there is a difference between the operational data available with the device and the real energy that the owner will obtain. Of course, the reason for this is the difference in standard conditions, STC, with actual operating conditions. This may shock the investor and negatively affect the spread of these systems' distribution in the Libyan market. From here, the objective of the study was determined to determine the causes of energy loss in the fields of solar cells installed on the roofs of buildings, which in turn will help the merchant, the installer, and the owner in understanding the reality of solar cells work and how to avoid energy losses. Energy losses in PV solar panels. The energy losses in PV solar systems may be classified into 4 types. As manufacturing losses. There are 3 major types of commercial solar panels on the world market today. There are 15. Monocrystalline solar panels, last the longest, high energy efficiency. Polycrystalline solar panels, lower efficiency than monocrystalline. Thin film solar panels, this type includes amorphous silicon, gallium arsenide, copper indium gallium selenide CIGS, and cadmium telluride, CDTE, least expansive, shortest lifespan, lowest efficiency, and most flexible. All these types have advantages and of course they have disadvantages also. Table 1 summarizes some characteristics of the 3 most common solar panel types. Installation losses. Tilt angle. Tilt angle of fixed-mode PV solar panels is considered as a critical parameter. Many efforts are made in order to determine the optimum tilt angle 17,18. Missing the optimum tilt angle leads to an attenuation of solar radiation. As a result, the production of the PV panels is reduced. For Tripoli Libya the optimum tilt angle varies from 0° to 50° during summer and winter seasons respectively. 17. while the optimum fixed tilt angle is calculated by AGA and Spada 19 and it found to be equal to 20 degree. Therefore, tracking mode PV panels receive more incident radiation than fixed mode ones. NASA shows that the increasing in solar radiation can be reached to 38% in case of dual axis and about 23% by using one-axis solar tracking system. 20. MS Excel working sheet is prepared to study the sensitivity of the solar radiation to the tilt angle. It is well known that the global tilted solar radiation is depending mainly of the sky diffuse and ground reflected transposition models and the albedo 21. Unfortunately, there are no time series readings for long periods of time for solar radiation, as well as there are no studies that determine the appropriate model for determining solar radiation on sloping surfaces, except for the city of Brack, Engineering and Technology faculty, where this study was conducted. Elsadic and Nasser indicated in an experimental study of the solar radiation in PV solar fields 22 that the Liu and Jordan model, 1963, is the most accurate model that represents the solar radiation data for Brack City. The obtained results show that the annual global solar radiation incident on a fixed tilted to 20 degree south facing solar collector is found as 2485 kWh/m2, while when moving the solar collectors once a month this will be augmented the solar radiation incident on the solar collector surface by 3.74%. According to the Liu and Jordan isotropic sky transposition model, the global tilted solar radiation will be calculated by 10. Shadow. It is a fact that shadow on solar harvesters reduces their output power, especially in case of PV solar panels. For this reason, that the presence of shade on the PV solar panels must be prevented. 23 to 25. The energy losses in PV systems due to the shading is approximated by 4%. 26. Shadow can occur as a result of the presence of objects around the solar field or as a result of the shadow of the previous row falling onto the next row in the solar fields. The presence of the shadow in the distance between the two rows also has an effect on the intensity of solar radiation as evidenced by experimental and theoretical researches. 22, 27. Figure 2 illustrates a side view of a horizontal solar field. The shadow calculations have been derived and presented in 25. Side view of deployment of solar collectors on a horizontal solar fields. It is a well-documented fact that shading of a PV solar array reduces its output power capability. However, the relative amount of such reduction in energy yield cannot be determined in a straightforward manner, as it is often not proportional to the shaded area. Many researches clarify the mechanism of partial PV shading on a number of PV cells connected in series and/or parallel with and without bypass diodes. Authors of 22 provided a simple analysis and can be useful to someone who wishes to determine the impact of some shading geometry on a PV system. The configuration considers two rows connecting in parallel and in series with diodes connecting in parallel with each row as it illustrated in figure 3a and b, respectively. The solar radiation intensity is considered uniform on the first row and some panels are shaded in the second row. The resulting IV characteristics of these configurations and the corresponding PV curves for the above two cases, in addition to the case with uniform solar distribution on both rows, are schematically shown in figure 3a, b. Maximum power point, MPP. MPPT is an algorithm embedded along with power electronic converter and load. It forces the PV module to operate at MPP in any given solar irradiance. 29. The feature that allows an inverter to remain on the ever-moving maximum power point, MPP, of a PV array is called maximum power point tracking, MPPT. The four-characteristic curve of PV modules includes the short circuit current value, ISC, at 0 VDC, the open circuit voltage, VOC, value at 0 A and ANI, the point where maximum power point, MPP, is found on the curve. This is the location on the four curve where the voltage multiplied by the current yields the highest value of power. Figure 5 shows the MPP for a module at full sun at various temperature conditions. As cell temperature increases, voltage decreases, and module conversion efficiency suffers. Other than temperature, module performance is also affected by sun irradiance. When sun is full, i.e. at irradiance of 1000 W/m2, module current is highest, and when there is less sunlight, module current decreases and so is conversion efficiency. Since sunlight intensity and module or cell temperature vary substantially throughout the day and the year, array MPP, current and voltage, also varies accordingly. The ability of an inverter to accommodate these environmental variations and optimize its performance to meet grid criteria and other regulatory standards, NEC, IEEE, and UL etc., at all the time of operation is achieved largely due to effective maximum power point tracking feature 30. 2.4 Environment losses. The performance of PV systems is generally affected by the real weather conditions. In the desert climate, dust accumulation is one of the main concerns that may cause a significant deterioration of PV efficiency. The analysis indicates that in a temperature climate, during days with high humidity intervals similar to the ones discussed in the paper, crystalline silicon modules have the lowest efficiency losses, followed by CDT, CIGS, and CIS modules. The results can be useful for PV system designers, installers, and end users of PV systems for a better system design and for a more accurate prediction of the daily energy production. 31. Estimation losses. Engineers and scientists predict the yield of a PV solar field using the methodologies described in many researches and commercial softwares. The input of these softwares are the manufacturing and weather data, including time series, historical temperature and solar radiation information. Therefore, the accuracy and reliability of the obtained results, which the decision makers will be considered to make their decisions very sensitive to the accuracy of these informations and the conveniently of these programs for use in a specific site. Nasser et al. 21 tabulated some wide-use commercial programs and the models used and tabulated in Table 2. It is clear from Table 4 that the cheapest price of energy production is the thin-film solar modules. This is due to the hot climate that Libya belongs to. Consequently, the decision of businessmen to import the polycrystalline solar modules is considered an economic mistake and causes great commercial losses to the customers. Figure 7 shows a comparison between solar radiations incident on a fixed and monthly adjusted tilt angle and the monthly optimum tilt angles. Comparison of several total daily global tilted solar radiation incident on fixed and monthly adjustable surfaces. Illustrates hourly shaded area percentage for the 21st day of each month of a solar field locates in Tripoli, 32.815 degree N, 13.439 degree, with rose height of 6 m, 20 degree tilt angle to the south, the space separating the rows is 6 m. Hourly shaded area percentage for the day 21st for every month of a solar field locates in Tripoli, 32.815 degree N, 13.439 degree, with rose height of 6 m, 20 degree tilt angle to the south, the space separating the rows is 6 m. Presented a pie chart illustrated the breakdown the energy losses in PV solar systems which must be taken in account during any study regarding the PV solar evaluation. Break down the energy losses in PV solar systems. 4 conclusions. The present paper discussed the losses that occurred during the operation of PV solar modules. The results can be useful for PV system designers, installers, and customers of PV systems for a better system design and for a more accurate prediction of the daily energy production. The study showed that the thin-film solar modules are the most suitable for Libyan climate, which is characterized by high temperatures in the summer season, and it is different from the type prevailing in the Libyan market nowadays.